Hello, everyone. This is Ben Chorn. I just wanted to share this presentation that I gave to the Minnesota Mineral Club. And if you have seen this presentation before, I gave this similar presentation in 2020, and I have upgraded this presentation with some new information and also added some new pictures and just upgraded it in general. This presentation is on Montana moss agates. I'll be going through a ton of different information, and I hope you all enjoy. So Montana moss agates are found in Montana, as well as some other locations. Today we are going to go over the descriptions and formations, etc., of agates. This will get pretty technical at the beginning here, so just stick with me and you'll learn hopefully a lot about agates in general. We'll also start going through some of the different Montana moss agate types, where you can find them, go through some of the history and different uses of Montana moss agates, as well as some good tips on how and where to find Montana moss agates. So as you might know, Montana is known as the Treasure State, and the Montana agate actually became the official state gemstone in 1969, along with the Yogo sapphire. So what is agate? Well, agate is made up of quartz, and quartz is composed of silicon dioxide. Just looking at the definition from Wikipedia, quartz is a hard crystalline mineral composed of silica, which is silicon dioxide, and the atoms are arranged in a continuous framework, forming a SiO4 tetrahedra. And these tetrahedra share oxygen molecules. And so you can see in the diagram at the bottom how these arrange to form sort of the classic six-sided prism or tetrahedra that quartz is known for. And in the upper part here, you can see sort of the another diagram as well. And this is something that you see a lot when you find the quartz crystals. These photos here are from Minnesota Mineral Club trips. The one on the left is from Judith Peak in Montana. These are what some people call Montana diamonds, similar to Herkimer diamonds. These are double terminated quartz points, smoky quartz points. And the one in the middle here, this is a clear quartz point that was found in Arkansas actually this year on a Minnesota Mineral Club trip. So looking through sort of a diagram of silica. So quartz can be arranged in multiple different ways. So we've got crystalline forms, micro or cryptocrystalline forms, and within those cryptocrystalline forms, you can have fibrous or granular orientations. And so we've got sort of the different minerals and terms on the left, and we'll try and match them up with the terms on the right. So to go through this, the first one we'll do is the crystalline form. And so the crystalline form would be quartz. And so the quartz is, as we mentioned, the tetrahedra that forms with the silicon dioxide. And if you then go into the microcryptocrystalline, which means you can't see visibly any crystals, if you were to look at sort of a granular, which would be, small grains of silica that have formed together, this would be chert. So chert is a granular cryptocrystalline or microcrystalline form of quartz. It's characteristically biological in origin, and it can also occur inorganically as chemical precipitants, which is part of a diagenic replacement, or part of a diagenic replacement. And diagenic replacement just means replacement during the formation of it. One special type of chert that occurs in limestone is flint. So if you've heard of flint before, it is just a darkish, usually dark gray or black form of chert. And then looking into your fibrous versions of microcrystalline quartz, this is what's referred to as chalcedony. So difference between chalcedony and chert would be that chalcedony forms as fibrous versions of silica, whereas chert is granular. And then looking into the fibrous version of chalcedony is agate. And so agate is a form of chalcedony, so it is a fibrous version of quartz. And then also looking into jasper. Jasper is similar to chert in that it is another granular form of cryptocrystalline quartz, which leaves quartzite, which is actually a name for a rock. And usually quartzite forms through a very heavy quartz-rich sandstone that gets metamorphosed. And so it is a rock that is completely composed of quartz. So just as a note again about jasper, it is an aggregate of microgranular quartz or cryptocrystalline chalcedony. So looking into agate then, agate is composed of silica, but also another mineral called moganite. And moganite is a mineral that was, it's a silica mineral that was discovered in 1976 in Spain. It was originally disregarded as just another form of quartz, but this was changed in 1999 when it was found that it has a separate crystal structure than quartz. So at the bottom here, you can see the one on the left that I showed before. This is how the quartz the silica ions or molecules form to form quartz, and then the one on the right is moganite. And if you want me to say the difference, I don't quite know because I'm not a mineralogist. The mineral moganite was actually named for the city of Mogan, which is in a island of Gran Canaria in the Canary Islands, which is part of Spain. So they both have the trigonal symmetry, but it belongs to the hexagonal lattice, making the difference with the monoclinical crystal structure of the moganite compared to quartz. There have been instances of moganite found in Europe, India, and also the United States. However, a totally pure moganite has never been found or synthesized in the natural state. So moving on then to more information about agate. So as we've talked about, it is a form of chalcedony, which is a type of quartz. It is a hardness of about 7, so a pretty hard mineral. As we mentioned, it contains both quartz and moganite, and chalcedony alone can also contain moganite. They've measured the amounts of moganite in agate and chalcedony and have found it to range anywhere from 2 to 23% by weight. The fibers for agate will grow in a helical fashion, and this grows perpendicular to the normal growth direction. So as you can see in this photomicrograph here, the bands are showing as the chalcedony that forms the agate is growing sort of perpendicular or sort of lengthwise instead of growing out like you would see sort of as a pointed quartz crystal that would be sort of growing up and in. As a reminder too, the hardest of 7, that is out of a scale of 10, so 10 hardest being diamond. So the first written record of agate was made by Theophrastus at about 300 BC, who was named it after the river Agates in Sicily. The agate is formed by a solution of the silica gel that will solidify in rock cavities. And the most widespread sort of host rock for this is basalts and andesites. You can also find agate in other materials such as fossil wood, as well as some different sedimentary rocks, particularly limestone. And the limestone, that's where you find a lot of, for example, Fairburn agates, TP Canyon, Bear Canyons, those are different examples of some limestone agates. The voids that agates form in are called vesicles, and this is what we would call a vesicular texture in a basalt. So these are your gas bubbles that get solidified into the rock, and these then create the holes that can then get filled with your silica solution to form your agate. The first detailed study of agates using thin sections were carried out by Timofeev in 1912, and you can actually see some of these micrographs here at the bottom which was sort of the first example of trying to really look into the molecular structure of agates to try to figure out how they formed. Other people have done work since then, in particular Lysing, who made different publications on looking at rhythmic banding of silica gels, which was done in 1915. A lot of the information in these sections here are based on um, a journal article that I found about agategenesis, talking about a continuing enigma, and is by Terry Moxon and Galina Paliova in 2020 from the Minerals Journal. I should also mention, these thin sections here were also based on agate amygdules that were found in basalts in Russia. And on the top here, this is a dyed Brazilian agate. And this photograph here shows sort of a version that you can see sort of the inner growths of the agate as it's growing sort of into the center of it. So looking again into the agate formation, as I mentioned, it forms with silica gel. And so what happens is this solution that is heavily composed of silica will enter this hole or this vesicle, and it'll lose some of the water. And that water will then basically precipitate out this amorphous silica. There's been some studies to try to figure out the source of where the silica comes from, and a large portion of it is from the leaching of the host rock. This was done, one of the studies looked at Hawaiian basalts and found, looking at a loss of iron, the trivalent iron ions, and looking at how the transportation of that can lead to leaching of the host rocks. And this has also been replicated in other studies that have found this in older host rocks. This could also be a large part of why, for example, Lake Superior agates, which have a lot of iron in them, would have formed in a condition that had a lot of iron in the environment. So this precipitation of silica is repeated, and that is then how agates are formed. They have found that usually the initial deposition of silica is usually what they would call a wall contact layer is usually much thicker and usually different. And that is evident here up in this photograph at the top, which is of a Botswana agate, where you can see sort of that wall contact looking different both in sort of normal light, and then also here under the micrograph as well. The first introduced aspects of agate formation were introduced in 1849. However, the solubility of silica wasn't known until the 1950s. The general consensus for the formation of agate is that it forms in rocks at less than 100 degrees Celsius, so relatively cool. However, different studies have shown that it could also occur up to temperatures that range to 200 degrees Celsius. Some of the studies have also looked at the varying ages of the rock versus when the agates inside of those rocks form. And some of these disparities found that for example, Chalcedonian Yucca Mountain that was formed around 4 million years ago. However, the rocks themselves were formed 13 million years ago. Some of the different Brazilian agates have found that they have actually varied by 100 million years after the initial rocks had formed. Some of the studies looked at mogonite content and found that that can be a function of age, usually looking at rocks that are less than 60 million years old. I should mention here that throughout this, there's been a lot of discussion on agate formations, and it is something that has been argued about in many different sort of theories as far as how agates are formed and the intricate details. Some of them have been sort of disproven by different agate types or just different sort of science in general. And so this is sort of the best information that I can find on agate formation. Just looking at sort of some of the chemistry of it, this chemical formula here shows how you can get silica, and then losing your water, you would get your SiO2 molecules, and then your water that would be left over and evaporated or transported out. And this diagram here at the bottom is just showing a different sort of progression between where you would have amorphous silica and then cristobalite or tridymite, and those are different silica minerals. And then that would go from cristobalite to your chalcedony or mogonite. And if you had enough time and space, that would actually start to form into granular quartz and even crystalline quartz as well. So your conditions do vary to depend on what sort of you're going to get in the formation. So this is just sort of a very general basic diagram showing sort of the progression of how you would get an agate. So you would have some kind of a volcanic eruption, or usually you would have this inside the earth, and so you would have your vesicles that would be able to freeze up in your igneous rocks in your magma instead of extrusive your lava. And as you have these vesicles that are left over from your volcanic activity, you would have an infiltration of water. So there have been some studies that have looked into sort of the source of the water, and you can do this by looking at your oxygen isotopes that are locked into the crystal structure of the agates. So your atmospheric or rainwater water is going to have a different oxygen isotope than, say, the water that is within the ground or your groundwater. So I'm not going to get into that, but just putting it out there that you can actually find that information as well. And so as your water, which is becoming saturated with silica, moves into these vesicles, it starts to deposit them into your agates. So then looking into Montana moss agates, some people have argued that Montana moss agates are not agates because they don't have banding. One sort of argument against this then is looking at Mindat. So Mindat is a great resource if you're trying to find information about different minerals. Looking at Mindat, it says moss agates, they freely contain a green mineral inclusion such as chloride or hornblende, or black to brown dendrites of iron and manganese oxides. So under this definition, Montana moss agates are considered a type of agate. One quick note here too is the black dendrites that you see in Montana moss agates are the manganese oxides, and your reds or browns, those are formed from your iron oxides. One thing that you will see in some of the agates is, for example, this lower one here in Montana agates, you can actually see more of your typical banding that you would find in sort of a typical agate. This is a agate here that I found by Terry, Montana. The one in the upper right here, you can see there isn't sort of visible banding that's continuous, but the dendrites are forming within these bands, which sort of shows it better here. So the one question might be, if there is banding in Montana agates, is it just possibly that we can't see it? So what if, for example, you would have a clear, unclear banding of Montana agates? And this is something that I really agree with, because if you look at for example, this picture here of a phenomenon that is found in Montana agates called iris, where the light is diffracted through the bands, you can see in the central photo here at the bottom that there really isn't visible banding in this slab, but then when it's polished and held up to the light, you can see the bands in this iris effect. So as we mentioned, the voids or vesicles in the volcanic rocks are where agates form. The voids can also be formed not only by gas bubbles, but also trees or other different whatever was encased in the rock that might be able to leave a void. So this photo here in the upper right, this is actually from Craters of the Moon in Idaho, and this was part of the Yellowstone hotspot volcanism. And this person here, Sean, he is standing in what is known as a tree mold, which is a tree that was present, which was then encased in the lava and then was eroded away and left this mold. And so if you find agate that filled in this mold, that is what people sometimes refer to as limb cast, because it is agate that is filling a mold that was left by either a branch or a piece of a tree, and then the agate sort of retains that shape. So one quick little pop quiz that I like to talk to people about sometimes. So if the agate forms in a pocket that is left from a branch or a tree, and we call those limb casts, could there be a limb cast of Lake Superior agates? And of course, that answer would be no, because Lake Superior agates formed in rocks that are a billion years old, and there weren't trees at that time. So if anyone ever tries to sell you a Lake Superior agate tree, a limb cast Lake Superior agate, that is not possible. It might just be a very sort of long vesicle that it formed in that might somewhat look like a limb cast, but if it is an actual limb cast, there's no way that it would be able to be a Lake Superior agate. So your Montana agates are found in gravel deposits of Pleistocene age in the area of the Yellowstone River. And so that's anywhere from 12,000 years to 2.6 million years for the age of those deposits, and also in the tributaries of the Yellowstone River. The source of the volcanism, then, of the rocks that these agates form in is from around Yellowstone National Park. However, this is not from the volcanic hotspot activity. You can find Montana agates in older deposits, such as the 6 Mile Creek and Flaxville Formation, which are somewhere in the 10 million years old range. And just as a reference, the largest agate that is believed to have been found from Montana agate is 63.5 pounds, and it was found in Jardine, Montana, which is just northeast of Gardner, which would thus be very close to the source. So going through then sort of the history of the Yellowstone National Park area. So this is taken from the National Park Service. During the Cenozoic era, which is approximately the last 66 million years ago of the Earth's history, there was a widespread mountain building, volcanism, faulting, and glaciation, which sculpted the Yellowstone area. The Absaroka Range along the park's north and east sides were formed from numerous volcanic eruptions of about 50 million years ago. This period of volcanism is not related to the present Yellowstone volcano. So if you were to look at this diagram on the right, this is showing your Yellowstone hotspot and its locations. So you can see here, it was first showing up down here in Nevada around, almost 20 million years ago. You've got the progression as it moves through Idaho and then into its current spot, which is around 2 million. Even on the border here, you've got your 6.6 to 4.4 million years ago for the Yellowstone hotspot. So if you look here, the first Yellowstone eruption is here at about 2.1 million years, but your Absaroka Volcanics, which forms the mountains in the area, that is your 40 to 50 million years ago, which would lead credence to, if you're finding agates in deposits that are aged to 10 million years ago, which would then be older than your first Yellowstone eruption, then the source had to be from somewhere else. And so your Absaroka Volcanics make the best sense. So this is a map just sort of looking at what the geography would have looked like and the landscape would have looked like during the Paleogene. And this is, again, that 50 million years ago when there was that mountain building and volcanism in Montana that thus created the host rocks to have your Montana agates form in. And so just zooming in into sort of your Montana area, you can see here down in the southern part of Montana, your mountains that are starting to build up and form, and then your large expanses of rivers, as you can kind of see here, your Yellowstone River flowing through as well. And we will get into that right now. So then looking at your source, so here's just a map of Montana and the Yellowstone River. And so you can see here the star. This is your area of your Absaroka volcanics that are providing your Montana agates, and then they are eroding out into the Yellowstone River. And the Yellowstone River is carrying it along and then up into North Dakota. This is another map here on the left from the Rockhound's Guide to Montana, just sort of showing some of the general agate areas that you can find. This shows, just a bit west of Billings, all the way into some of these tributaries and up sort of to Sydney. So the question then becomes, was this always the orientation of the Yellowstone River? Or was this always the path the Yellowstone River took? If we're talking 50 million years that we've been creating and eroding and depositing Montana agates, what was the Yellowstone River doing this time during this time? So a lot of these figures and maps that I'm going to be showing you here come from an article called Geologic History of Montana Agate. This was written by Ron Longhurst, and this was published in the Lapidary Journal in September of 1977. And this is a stratigraphic column, or just sort of looking at the rocks through time of the area. This is showing here your ages on the left, and then the formations. Some of these formations, as you cross borders, will change names. So for example, Your Flaxville gravels, which are known to include Montana agates. Once you cross the border into Canada, into Saskatchewan, this is also known as the Wood Mountain. So if you look at the Flaxville and Wood Mountain formations here, it says brown, yellow, grays, gravel, sand, silts, marl, and volcanic ash, quartzite chert, and agate gravel that is partially cemented by carbonates. And so this is found in the Oligocene, and this is what is known to be from 3.3, or sorry, 33.9 million years ago to about 23 million years ago. And you've got some Flaxville, which is late Pliocene, around 10 million years ago. And you can even get then going back further into your tertiary deposits as well, which are resting up along some of your Fort Union Cretaceous age rocks. So this is another map. This is from a different article. This one, I believe, has really helped in sort of expanding sort of my knowledge on sort of the distribution of Montana agates. And this is from an article called Comparative Analysis of the Source Gravel and Sand Deposits, a pre-contact lithic resource in southwestern Manitoba. This is taken from some research that was done from the Department of Anthropology from the University of Manitoba in Winnipeg. And this was looking at the artifacts that were found in Native or First Nations areas within this sort of inset map here, which is near the Source area of Manitoba. And so this is somewhat important because if you are finding, for example, obsidian knife points or arrowheads or spear points, you might want to try to figure out where that came from, because if it is from a nearby resource, or if it is from some place like, say, Idaho or North Dakota, then you might give credence to the fact that these peoples would have been trading to get these resources. And so this was looking at sort of the deposits of different artifacts and also the materials within the area of source to try to figure out the source of where this may have came from. And so this map here is showing modern day rivers and also pre-glacial river valleys. And I've outlined some of the important parts here in different colors. So this red here is the current orientation of the Yellowstone and then into the Missouri River. So you can see here, the Yellowstone River is following its current course, goes up past Glendive and Sydney, and meets up with the Missouri River near Williston, where then it flows to the east and then south. However, if you look at the pre-glacial river valley, it more or less follows the current Yellowstone River until it reaches the Missouri River, and then it keeps flowing north, and it goes up into near Estevan, Saskatchewan, and then up into Manitoba, where then it would have continued to flow towards the north and exit the waterway that way. And so again, looking at this, you've got what they call the source basin in this area where the pre-glacial Yellowstone River used to flow. So going back again to that previous article I mentioned, Lapidary Journal, this is another more sort of geological map of the area. And this is looking at approximately 40 million years ago with their agate-bearing gravels and where they were deposited. And so you've got your mountains over here, you've got your Bear Paws, down here, your Bighorns and different other mountains to the west and to the south. You've got your pre-glacial Yellowstone River, which is depositing gravels, as well as some of these pre-glacial Missouri River deposits here too, depositing your Flaxville gravels in the area, which again, this is the Wood Mountain gravels across the border into Canada. And so again, you've got your pre-glacial Yellowstone River flowing up into Canada near Estevan and then into Source. So we're going to talk about Source for 1 second. So this leads the question then, if the Yellowstone River used to flow into Source, can you find agates, Montana agates in Canada? And so this was taken from the Source Glenwood website, which talks about some of the things you can do in the area. And one thing that they've mentioned is the Source agate pits. And I'm not going to read all this, but just sort of showing you here that it is a 12-acre glacial deposit that is known for agates. And so if you go someplace like, say, Mindat, and you search for agates, you can see agates from the Source gravel pit that people have posted. And this photo here on the left is a very good example of some of the typical agates that you might find in Montana, with, sort of these black dendrites. This one here is what some people call sort of like a honey agate with that sort of yellowish honey color. And then this here too is a piece of petrified wood, which looks very similar to what you can find on the Yellowstone River today. So I went through then to try to find some more information and try to contact some people to get some photos to just sort of prove that these agates that people are finding in Soros are Montana in its source. And so I was able to get into contact with someone named Daniel McKay, who put me in contact with Corey Sylvester, who does a lot of picking in the agate pits in Source. And so you can see here, this is just part of my conversation where he said, most of the agates and petrified wood that I find in Source, Manitoba, I think have Yellowstone River origins. So you can see here, all of these photos look exactly like agates you may have been able to find in Montana. And this is more evident by the fact that I actually showed you one of Corey's agates earlier in the presentation, and it probably slipped by everyone just thinking it was just another photo of a Montana agate. So if you want to rewatch and go back earlier, you might be able to find that photo. But you can see here, these all have your classic sort of black manganese dendrites, and then also sometimes your iron oxides that form your browns or your oranges. So going and revisiting back this map here, so I've added some more colors and expanded this a little bit, but you can see here, so in red is your modern day Yellowstone River as it flows north until it meets the Missouri, and then it follows the Missouri River down through the Dakotas. The modern day Missouri River more or less follows the pre-glacial Missouri River. This part here, I did extend it up. I do know the Missouri River falls down through Great Falls, but you can then, of course, see your pre-glacial Yellowstone River going north. So the question then becomes, why did the Yellowstone River then stop flowing north into Canada? And also here you can see the Missouri was also flowing north as well. So this boundary here of the Missouri River that I've outlined here in the yellow and then the red, you can see if I overlay this map here onto it, you can see that it matches that pretty good. So if I go back again, following the Missouri River here, you can see that this map follows that really well. And so the question then becomes, what is this map showing? And this map is the extent of the Laurentide ice sheet. So when you've got your glaciers that are coming from Canada and flowing down into North America, you've got this huge expanse and very thick ice sheet that is advancing. And so if you have a river that is trying to flow north, when it hits this wall of ice, it can't flow north anymore and then has to alter its course to get around it. And so you can see here, this is the Missouri River, this dark blue here, and then your bright blue here. This is your extent of the ice sheet. So then going back to these maps, again, this is from 40 million years ago. So pre-glacial, before the glaciers came down, you can see your Yellowstone River, which is flowing into Saskatchewan and meeting up with the pre-glacial Missouri and flowing into the Source Basin here and continuing out that way. So this was one of the advances of ice. This was actually a little bit earlier. So this was from 200,000 years ago. And you can see here these dashed lines showing the pre-glacial outlines of the rivers. And so this was 200,000 years ago. So you've got your ice advancing. You've got different glacial lakes that are forming as they dam up these rivers. You also will have some of the flowing water of the melting ice sheets, which can start to form deltas. And so you've got some of these deltas that are forming off of those, but largely your deltas that are forming into sort of these glacial lakes. So you've got a large delta that actually was forming around Terry. You've got some parts of the Flaxville gravels that were not touched by the rivers or the advancing ice sheet, which you can still find today. And then looking then to the next glacial cycle, which was our latest glacial cycle of 20,000 years ago, you can see here the damming again of the rivers, and this is again the sort of modern day Missouri River that's flowing through here. You've got again your deltaic formations that are actually being reworked by the Yellowstone River in this as well. There's some evidence going through sort of Terry and Glendive of the old lake shoreline. Um, so this again just showing sort of through time the changes of the Yellowstone River. And then, as I mentioned, kind of getting more towards current. So this was about 12,000 years ago. And so you can see here Yellowstone River, which used to flow up into Saskatchewan and then into Source, is now changed. Where part of that is now occupied by the Source River, which flowed into this basin, the Source Lake Source and the Source Basin. And then now you've got your Yellowstone River, which meets up with the Missouri River, which largely mimics the extent of the ice sheet and flows now to the east and to the south. So if you were to look at this in cross section, basically cut the Earth in half to kind of look at it from the side, this is what you would see here. So this is looking from close to Cody and then up through Canada. So again, you've got your mountains here on the sort of the southwest side. Some of these are tertiary deposits of agates that you can find. And then you've got, looking through these different river valleys, you've got your Yellowstone River, which cuts down into some of your different formations, your Bear Paw shales and such. Going through, you've got your Missouri River and then your deeper cut of pre-glacial Missouri that you can find. This sort of hash mark and stuff here is your glacial material. So reworked material, which is capping over, as you can see here, some of this red. And this red I've highlighted is your Flaxville or Wood Mountain gravels. And so along the Missouri River, you can see some of this Flaxville gravel outcropping. Some places underneath your glacial material, you do have some of your Flaxville. And you can see some of these old river valleys that were cutting through your Flaxvilles and also some of your others. So this just trying to show you that if you were to get through some of your glacial material, you can find your Flaxvilles. This glacial material also was reworking some of this material. So you can find a lot of Montana agates in this glacial material and also in these old river deposits. Just looking at this map, you can see here that some of these deposits then are much higher than the current river valleys. So to sort of prove this, these are some different photos. So as I mentioned here, as I just mentioned, if you can find agates in the Yellowstone River now, could you find them then where the Yellowstone River used to flow, both laterally? And then also, does that mean you can find them vertically? So this picture on the left, this is from Seven Sisters near Crane, Montana. So you can see your wide expanse of gravel of the Yellowstone River today. This was from the Minnesota Mineral Club trip in the ranch just north of Glendive. And so you can see here, this hill that I'm standing up on top of here, I found, I think it was about 4 or 5 agates that were all over a pound, and 3 of them were over 2 pounds. And this hillside here was just littered with Montana agates. And so, and this creek here too. And you can see, you can't even see the river. It's all the way over here, where it's 2 miles away. And the current elevation of the Yellowstone River is just over 2,000 feet. And the hill that I'm standing on is over 2,200 feet. So almost 200 feet of elevation of change between where I'm finding agates and then where the Yellowstone River is today. And this photo here on the right is more closer to the Terry area. And you can see here that I am over 4.5 miles away, straight shot from the Yellowstone River. And I am finding this bunch of gravel here. And the elevation of this area is about 2,860. And the current Yellowstone River, as close as I can get to this spot, is 2,140, which means that I am over 700 feet higher than the current Yellowstone River. And I have all this gravel here, which you can see sort of a better picture here. And so I did find Montana agates in this gravel here, and you can see how it sort of caps off this Cretaceous rock here all along up on the hillside. So going through some of the different uses and just the history of the Montana agates, um, Native Americans were using different heat treating methods to better work Montana agates and petrified wood. This also included the Knife River flint, which is found in North Dakota, as well as some other stones. This here was taken from the Fish and Wildlife Service talking about Lake Ilo. So again, we mentioned the Source, Manitoba, some of the Native well, I guess not Native Americans, but First Nations people in Canada that were using it to use for different materials for arrowheads and such. And this is from Lake Ilo in North Dakota, which just mentions, that about 10,000 years ago, there were just different people in the area that were working with nearby Knife River flint, petrified wood, porcelainite, and also Montana moss agates from the Yellowstone River, as well as obsidian from Idaho. And this photo here, this was a modern day arrowhead that was made. This is by Jim Miller. And this photo here on the bottom, this is just showing some of the Native American cave drawings that you can find at Pictograph Cave State Park in Billings, Montana. So if you're ever in Billings, Montana, I highly suggest you go and visit that because it's a pretty cool area. So jumping ahead to looking at when people were using Montana agates for a source of as a mineral source, this is in our snapshot, of the USGS Bulletin of Useful Minerals of the United States from 1917. And as you can see here, they mention agate from the Yellowstone River. And this was taken from the USGS here. Again, Montana moss agates are grayish white to gray translucent chalcedony containing dendrites with black, brown, or red tree-like or scenic dendritic growths that are included minerals of manganese and iron. And again, you can find them from Billings, the Sydney, and a lot of the different counties mentioned here as well. And they are sought after because of their beautiful and highly variable patterns, durability, and ease in cutting and polishing. So going through then, now that we've got sort of the mineral importance of Montana agates figured out, the first sort of the history of this then became as Ralph Harris was known as the first commercial cutter, and he was in Miles City in about 1915, and he actually operated until about 1958. There was also someone slightly earlier, believed to be John S. Larimore, who started cutting agates in 1914 near Glendive. This expansion of Montana agates and cutting actually led to agates being shipped to San Francisco in 1919, 1920. This was, quote, by the carload, that they were loading up Montana agates into train cars and shipping them to San Francisco to be used in different jewelry and different lapidary applications. This actually suddenly and almost abruptly stopped to where they actually had train cars loaded with a shipment to go to San Francisco. And when they suddenly just stopped, it was rumored that they took the entire train car loads of Montana agates and dumped them in the basement of a bar in Miles City. And supposedly the basement that includes all these agates was never found. A lot of these early cutters had to actually build their own equipment to cut these agates, which include saws and also the blades that cut them as well. One of these early cutters was Howard Sissel. He began gathering agates around 1912 in Sydney, Montana. And in 1927, he actually built a saw then to cut these agates, which led to him setting up a lapidary shop in Sydney, Montana. Later, he actually attended Northwestern University and the Chicago School of Jewelry and Watchmaking. Howard Sissel passed away a few years ago, and these photos here are actually from Luke Rudolph, except for the one on the lower left here. And these are agates that were from Howard Sissel in his collection, and this lapidary piece of equipment here was also from the Sissel estate as well. Apparently, Howard Sissel liked to collect other things, and so this lamp here was also an antique that Sissel collected as well. A lot of people know Tom Harmon right now, who is pretty famous for writing books on Montana agates, and has some really amazing carvings and different Montana agates that he produces right now. Tom Harmon recently mentioned that he started collecting agates at the age of 6 years old, and he found him on gravels on his playground with his friends, and they would go and sell them to Howard Sissel, who would give them money for them, and then he would turn around and go and buy his pop and candy with that money. So there are photos here at the bottom. These actually, I'd like to thank Luke Rudolph for these. These are actually agates as well from Howard Sissel, as well as a piece of jewelry cleaner from Sissel. And as I mentioned too, there are a lot of rock and lapidary shops today in the Yellowstone River area. So looking at some of the different Montana agate types that you can find, most people, as I've mentioned, have known about the sort of dendritic or spot agates, where you get some of these really cool designs of, again, black is manganese and sort of your reds or browns are your iron oxides. You can find, as I mentioned, sort of your typical banded Montana agates. And so a lot of these are more your yellow or whitish colors. You can find a sort of your true moss agates where you can have sort of this mossy look to it. This is a photo from Jeff Nesper. And you can also find sort of your typical waterline or water level agates that you see in a lot of different other agate types. You can also find botryoidal. Again, botryoidal is the term that is known as sort of grape-like is the definition of botryoidal. Sort of that sort of bubbly, bumpy look to it is what's called botryoidal. So you can find different botryoidal Montana agates. Very, very rarely you can find blue agates in Montana. I have found actually just a couple of them. This is one of them here. It actually does have some faint banding in the middle part of it here. And this was found west, more closer to Billings. And then these are known as sort of your painting or scenic agates. There was one person who, in trying to look at the formation of agates, proposed that Montana agates were formed by sort of these globs of silica that were sitting on the surface and sort of absorb the photograph of the scenes that were around them, and sort of captured those scenes in the agates. So these are some other scenic agate types. These two on the left are ones that I found. This one on the left here, this is one that I actually found this year on the Minnesota Mineral Club trip. And so part of these scenic agates are sort of patterns that people think look like a different scene. So this one on the left, I've had people tell me that it looks sort of like a cliff on the Superior shoreline. We've got some trees and maybe the cliff falling into the lake. This one here sort of looks like a sun with some trees. This one on the right here could look like either mountains, or people have thought maybe it looks like waves of an ocean with sort of a rising or setting sun as well. I mentioned this before, but you can also find iris. So the iris refracts the light. You usually have to cut the cab pretty thin to be able to see it, and it usually doesn't show up until you polish your agate as well. Some people that I've talked to have proposed that because of these clear unclear bands, that almost any Montana agate can have iris. But unfortunately, from my experience in talking to other people, that's not quite the case. So it is a fairly rare occurrence, but it is pretty spectacular when you find it. And so these are some photos from Facebook showing some of the iris effect. As I mentioned before, if you find agate that was formed within a mold that was left by a part of a tree, that's called a limb cast. And so these are some different limb casts, Montana agates, shown here with a photo from Facebook as well. So now that you see all of these Montana agates, you might be thinking, okay, this is wonderful, but where and how would I be able to find these agates? So as we've mentioned, you can find them along the Yellowstone River. This is taken from one of the rock hounding books. You can see sort of the agate area is mentioned from Custer all the way up into Sydney. As we've talked about, you can also find them in places where the Yellowstone River has been. So again, up on top of a hill. When I mentioned this earlier about how I'd found some large agates on top of a hill. This is actually me with some of those agates in this photo here on the left. And as we've shown, you can even find them up into Canada. And this is just a short video. I'm actually going to try to link this in the video. So if you would like to watch it, you can click on the link in this video. The video is called Why Do Rivers Curve? It is from the Minute Earth series. So it is just a couple minutes long, but it goes into details about sort of the morphology of rivers and the features that will be caused from rivers. Okay, so now that we kind of know more about the rivers and how they form, we can use that to finding Montana moss agates. So these are photos that I took of different areas in Montana. So this here, you can see the Yellowstone River and then some of the gravel, and you can actually use the vegetation to sort of know where the newest and freshest gravel is. So you can see closest to the river, there is no vegetation, and you start to get into sort of some sparse vegetation, and then, more a lot more grass, and then really heavily vegetated, even up to them where you can have trees that are forming. So if you were going to look for agates, you might think, okay, well, I want to go and look where the freshest river gravel is, which, right here is closest to the river. These photos here on the right are from this area. And this photo on the upper part here, this sort of expansive sand and gravel bar, this is actually just north of this photo, but it's very similar to this sort of gravel bar here. And you can see this on Google Earth again, where you've got no vegetation, a little bit of vegetation, heavier vegetation than even trees along where the oldest outside of the Yellowstone River that channel is. However, again, you can look at areas where the Yellowstone River has been, and if you were to look at this map and sort of zoom in, you can see this area here, which sort of has these small sort of drainage structures, and looks a little bit more gray. And this is because of the gravel. So the Yellowstone River used to be outside of its banks and deposited this gravel all over. And this photo at the bottom here is actually taken from this area where you can see some vegetation. There's actually some cactus, which is something to look out for. But they actually found a lot of Montana agates in here. So it's important to remember to not only look at where the Yellowstone River is, but also where it's been. So here's another map sort of showing the Yellowstone River. And again, as we learned from that Minute Earth video, on the inside of the curves of the rivers is where you're going to have your point bars or your deposition of agates. This is Huntley, just outside of Billings, Montana. And you can actually get down to the bridge here, and then you've got this whole expansive gravel area to search. And you can see not only on the main parts of the Yellowstone River here on the inside of the curves, you have all this expansive gravel bars, but as you start getting into some of these more inner curves, all of these on the insides have smaller gravel bars as well. And if you look into some of these old channels that you can see here, some of the inside curves, you can actually see gravel on the old curves as well. And also remember that there's Yellowstone River gravel everywhere, and so don't completely disregard cut banks. Cut banks are on the outside of the curves, and I think these are some of the most fun areas to pick because when you're walking sort of along the cut banks as the river is down low enough, you are looking at agates that are, right in your face. And so this is just a reminder to also look at exposed cut banks that are cutting through old Yellowstone River gravels as well. So now that we know some of the areas of where to find them, how do you identify Montana moss agates? So again, they are a pretty hard mineral, again, a hardness of about 7. The agates have what's known as a waxy luster to them. So not really dull, not very shiny, but sort of waxy. Think about like a crayon. Sometimes you'll see what are known as chatter marks. These are sort of conchoidal fracturing. I heard someone mention these as impact scars. So as the agate is tumbling down the river, it's hitting into other rocks, and that sort of outside husk of the agate can get sort of beat up by that. And so I think impact scars is a really good term for that. If the agate is left out for a long period, it can actually get this sort of white colored sun bleaching that will occur. And this is something that if I ever see this white color, I usually immediately try to pick it up and see if it's an agate. Sometimes this is completely obscuring sort of what's inside, so it's hard to see if there's dendrites. Other times, again, if you've got sort of a clear on clear banding, this sort of sun bleaching will actually show the banding and really improve that banding look of the agate. You can also look at sort of the shape. So again, agates form in vesicles or molds left by trees, and so sort of looking for some of that more rounded sort of shape to it can also help in finding Montana moss agates. And you can also look for sort of the glowingness of it. The more honey type agates, which don't have much dendrites, will actually just glow in the sun. If it does have a lot of black dendrites in it, the agate will look almost completely black. One of the Minnesota Mineral Club trips, we were in a gravel pit outside of Glendive, and I actually found a almost completely black Montana agate that was about this big, that I had found multiple footsteps literally right next to it that people had completely missed because it was a full nodule. There weren't windows to it. It did have a bunch of those impact scars, and it was very, very black because it was full of dendrites. So here's some more pictures of sort of what to look for. So the one on the left sort of shows a what we might call a window. So looking into it, you can see here again that sort of roughened up husk on the outside, and then your dendrites in the middle. This one on the right is a photo that I took showing that sort of glow that you can see when the sun is at the right angle. And it just really makes the agates just stand out and literally glow at you. So again, shape is another one. One of the things that you can look for as far as shape goes is sort of that pitted texture. Because they formed in gas bubbles, you can see some of that sort of pitted or bumpiness to it. This is also something you can use to help find other agates, such as like superior agates. The other thing to look out for are what are called epimorphs or crystal impressions. So if there was a crystal in the void when the agate formed, it sort of formed around that crystal. And once that crystal is gone, it leaves this impression of it, which is why people call it crystal impressions, or the technical term is an epimorph. And so if you see something that looks like that on an agate, or on a rock, it's very likely an agate. And so these are just some examples here of some agates I found. Um, Again, the sun can sometimes really help even when the rocks are covered in silt like this. This one did catch my eye a little bit from the sun, but also you can see sort of the darker spots to it. And then these pits that you can see here on the right side, that is a giveaway that is an agate. And so this one here, you can see after I rinsed it off, is definitely an agate. So just sort of going through, so hopefully you know where, or sort of know now how to find some of these agates. So these next few slides, I'm just going to show some photos of agates that were found sort of in the wild, and we're going to see if you can identify them. So I'll just give you a couple seconds here to see if you can find them. So hopefully this is pretty easy. This one here is right smack dab in the middle. Again, it's got kind of that waxiness to it. That's the giveaway to look at that. And then this one here on the right, you've got that waxiness, but also again that's sort of the crescent or C-shaped impact scars, which is a dead giveaway of usually agate, sometimes chalcedony or other silica minerals, but something you definitely want to pick up if you see that. And then the one on the right, zoom in a little bit, you can see sort of the husk of it, and then a little bit of a clearish window here of that waxy agate. And hopefully maybe you also saw at the top of this photo here, there's definitely some quartz and maybe some agate sort of around it at the top of this one. Definitely would want to look at that. So here's another one, hopefully fairly obvious, but again, if the agate has been sitting out for a long period of time, you might see this sort of white sun bleaching that occurs. And so this one here in the middle, you can see sort of the agate broken window on the side of it, and then this white sun bleaching that's sort of coated the whole husk of it. This one here, hopefully you can see, um, this is some of the more, as I mentioned, honey agates. So again, this one right here, you can see the sun just glowing and lighting up the agate up here. This is another agate that I found. I found this near Terry. This one, I started to dig into it, so there actually was less of this that was shown. That I just saw just a little bit sort of that waxiness, just made me stop enough to try to dig it out. And this was the agate here, which I had shown a picture of earlier, of what it looks like after I got out of the ground. And this one was, I believe, just over a pound. So looking at some other photos here of agates. So this was, again, I really like looking at cut banks sometimes. So this is from a cut bank. So we'll see if you can spot the agate here. If not, here's a zoomed in photo. So you can see here this dark color waxiness. So again, agates don't necessarily have to be white or gray or even really black. Sometimes they can be sort of this brownish color like this. So you can see this is it sort of down here in the original photo. And this was when I pulled it then out of the ground. So again, you can kind of see that waxiness. It does some really cool bands to it. And this one, I actually did tumble. You can see it sort of removed some of that iron staining that sort of yellowish off. You can see a lot nicer of the bands and some of the black dendrites in it. So here's some more photos. So again, I'm just going to give a couple seconds. Hopefully you can spot them. These ones are a little bit easier to find. So this photo on the left actually has two. Again, this white sun bleaching is definitely something you want to pick up. Just below that, you've got this waxy, sometimes this almost bluish color that'll show up in Montana agates. These are two agates right there. This one here you can see is more of that sort of that honey. Again, it kind of glows in the sun, and this one at the bottom really glows in the sun, and a little bit hard to see, but this darker sort of waxy looking rock here is definitely something that I would pick up. So here's some more. Hopefully the one on the left is a little bit easy. The one on the right might be a little bit more difficult. But again, if you ever see a rock that looks like it's got these crystal impressions to it, definitely pick it up, because you're not going to have a basalt or something that has crystal impressions in it like this. And then this one, again, you've got sort of that white sun bleaching, and then there's also another smaller one right here. This, you can see I've gone a little bit further downstream, so the rocks are a little bit different. So this is, I believe, in the like Glendive to Sydney area. So you can see the rocks are a lot more brown and orangish in color. So this one, again, hopefully you can find them. You've got this, again, that waxiness look to it. Definitely an agate. Again, sometimes these, angles can be crystal impressions. And then over here, just sort of getting that waxiness look to it, that you can see sort of sticks out. And sometimes, again, those impact scars you can see will really help you out too. So besides Montana agates, you can find other things. So the Yellowstone River, you'll find a lot of this petrified wood. This on the right here is what it looks like unpolished. These are all polished. They're mainly composed of silica, so they polished really well. This one on the right also has the small brachiopod fossil that I found. This was found near Miles City. You can also find stromatolites. Stromatolites are fossilized algae, so you can see these mounds of algae as they were growing, that then became replaced with these minerals that hold the structure in place. Stromatolite fossils are pretty fun to find. You'll also find a lot of different teeth. Bison and cow teeth. It's sometimes really hard to tell the difference, but you can also find entire bison skulls, some of the extinct species of bison as well. Some people have found those, which are really cool. And rarely you can also find agates of other colors. I mentioned blue. This is a small green one that I found as well. So we talked about being able to find agates throughout Montana and up into Canada. These agates here were found somewhere else. These are all photos that I took of agates that I found. So hopefully you can see these and think that these look exactly like Montana agates. This one here on the left is actually botryoidal, sort of a honey agate type. And then this one here, this is the two sides of this red one, does also have some botryoidal, but it's got the black manganese dendrites and a lot of the iron oxide in it. So these agates were actually found, again, by me in Minnesota. People that find these in Minnesota refer to them as honey agates. And so hopefully through this, you might be thinking, well, okay, if the agates were found in Montana and Canada, well, then how are they also found in Minnesota? If you look at the current Missouri River, which does flow towards the east from Montana, it goes down through the Dakotas and bypasses Minnesota. Well, if you look at a map of the Laurentide ice sheet and where the glaciers came down from Canada, you can see the Des Moines lobe, which originated up here in Manitoba, Saskatchewan, and flowed down into Minnesota and the Dakotas during the last glaciation. So, as you remember, the Yellowstone River was flowing from Montana up into Canada and deposited Montana agates in this area, in the Source area, in Estevan. And from there, you can see the glaciers push them down. So I think it's a really cool story that if you find Montana agates in Minnesota, these are agates that formed from rocks in the southern portion of Montana, were transported from the river up into Canada, and then the glaciers push those from Canada down into Minnesota. So just think about the journey that these agates took the next time you find these in Minnesota. So I just like to wrap it up. This is a poem that I really like. This is from Meanderings of a Montana Rockhound, the book by Paul Fry in 1972. So there are hounds, you know, that hunt the fox. Now we are hounds that hunt the rock. We have rocks in the car, rocks in the shed. Some even say we have rocks in the head. But we love to hunt them on river and hill, and to cut one in two is always a thrill. Although you may travel far from your home, you'll find nothing as grand as a good agate stone. God hid them in his mysterious ways so that we may find one in our time and day. So we might dig and hunt and hike. Each one is different, no two are alike. To be out there in your walking shoes is always the cure for the worst of blues. So come with us and have a good look around, and you may become an avid rock hound. So some of the sources that I didn't mention are listed here if you would like to find some more information. And if you have any questions, please post them in the comments below. Just to kind of show off, this is one of the agates I found on the Minnesota Mineral Club trip to Montana this year. This is the rock that it looked like when I found it. This was when I cleaned it up. And then when I went through and polished it, this is what it looks like, which I had shown earlier. So thank you everyone for watching this presentation. And again, let me know if you have any comments. Thank you.